Here is an explanation for the answer to final exam, question number 81, on page 384 of Trigonometry Demystified, 2nd edition. Please refer to figure exam-10 at the bottom of the page, which is reproduced here with some color embellishments and a little bit less detail, but I also include an important formula. The question shows how a concave mirror forms a real image at a focal point. Here's the object. The light rays go like that. They pass through this focal point, which is right there. The focal length is F, and they form this image. So the light rays bounce off the mirror and they form this image. That is a real image. It's called a real image because it can be magnified, for example, with an eyepiece like you'd have in a telescope, and you'll actually see the object. Suppose that the initial distance r sub 0 between the mirror and the object equals 1.2 times the mirror's focal length f. Okay, this is the object, this is f. Now this is actually a little bit of a trick question, because if this r sub o here is really only 1.2 times the focal length, then we should take this figure exam-10 and put the object here. Then this would become r sub 0 right here, or r sub o for the distance to the object. Okay, the distance to the object is 1.2 times the mirror's focal length. If we increase that distance to 12 times the focal length, what's going to happen to the distance between the mirrors and the object's image? Well, let's just actually calculate how far away this image is going to be. Let's say that the focal length is 1 unit, whatever that is, 1 meter. But it can be one arbitrary unit. Here is the formula that we use that relates these quantities. 1 over f equals 1 over r sub I plus 1 over r sub o. Well, we know f, that's 1. We don't know r sub I. Now this is the image in this initial situation. So this here is r sub I. But we do know r sub o. That's 1.2. Well, it turns out that 1 over 1.2 is equal to 5/6. Because the ratio 1 to 1.2 is the same as the ratio of 5 over 6. That'll just simplify our calculations a little so we don't have to resort to a calculator quite as often. Well, now we have an equation which pretty well gives away this value right here. It's 1 over 6. So this equals 6. R sub I equals 6. So the image is actually 6 focal lengths away from the mirror, and the object is only 1.2. Well, the question says, what happens now if we move this object out here, making this r sub o, r sub I. Here's the image. What happens if we move this object so that it's 12 times the focal length? Well, now we have the situation, remember the formula, 1 over f equals 1 over r sub I plus 1 over r sub o. Now r sub o is 12. So this particular value, again, our focal length is, we're arbitrarily considering it to be 1 unit. This now becomes 11/12. Well, what is 11/12? That means that if we invert this, remember this is 1 over r sub I then becomes 12/11, just a little more than f. So whereas before r sub I was 6 times the focal length, now it is just 12/11 of the focal length, just a little more. So that means that the distance to the image has decreased a lot. Decreased a lot. That's the best choice here. Our choices here are A, we can't define it because the image will vanish. Well, no, it won't. It'll still be there. The other choices, it'll increase slightly. No, it doesn't. It decreases. C, it will increase a lot. No. D, it will decrease slightly. Well, no, I wouldn't say that. I'd say E. It'll decrease a lot. So that is the correct answer to this question. You might be able to ascertain this if you know a little bit about optics without having to make any of these calculations, but if you calculate, you can verify it decreases a lot.